Did you know that over 1 million knives are produced globally every single day? That's enough blades to supply every household in New York City within just 24 hours. The journey starts with computer-controlled machines shaping the knives. This step thins out the blade, especially at the tip, to create that sharp edge. You know what's crazy about perimeter polishing and grinding? Those machines are like magic. They shape the blade with such insane precision, it's almost like the knife is getting sculpted pixel by pixel. It's wild how they can get that tip so sharp while keeping everything perfectly balanced. It's like knife making on a whole other level. Washing. Once shaped, the knives still have shavings and metal debris from the grinding process. They're washed to clean off any remaining bits of metal, ensuring the next steps start with a smooth surface. This is where things get cleaned up, literally. After all that intense grinding, the knives are covered in tiny shavings and bits of metal. It's like giving the knife a little spa treatment, scrubbing off all the debris. Rough polishing. This stage involves sharpening the knife, but it's not the final step. It's meant to shape most of the blade while leaving room for finer adjustments. The rough polishing step is like the knife's first big makeover. It's not the final look, but it's where the blade really starts to take shape. The knife gets sharpened, but there's still room for those little tweaks later on. It's kind of like sketching out a masterpiece before adding the fine details. You can already tell it's going to be sharp, but the real magic happens in the next steps. Surface polishing. A skilled craftsman polishes the blade to a mirror-like finish, a delicate process that brings out the shine and beauty of the knife. Surface polishing is where the knife truly gets its glow up. A skilled craftsman takes over, carefully polishing the blade until it shines like a mirror. It's a delicate process that's all about precision and finesse. This is when the knife goes from a rough tool to something that's not only sharp, but beautiful. It's like giving the blade its personality, making it stand out with that flawless, shiny finish. Using a whetstone carefully chosen for the knife's characteristics, the blade is sharpened in several stages, producing that super fine, razor-sharp edge. Using a specially chosen whetstone, the blade is honed in several stages, each one bringing it closer to that razor-sharp perfection. It's a meticulous process that transforms the blade from just sharp to unbelievably precise. Handle polishing. The wooden handle is then polished until it becomes smooth and sleek, giving the knife a comfortable and attractive grip. It's all about making sure the grip is not just comfortable, but also visually appealing. This step is like adding the perfect finishing touch, so when you hold the knife, it feels as good as it looks. Clamp polishing. This process smooths the transition between the handle and the blade, creating a professional, seamless appearance. This step smooths out the transition between the handle and the blade, making the knife look like it's been seamlessly crafted from one piece. It's the final touch that ensures everything looks sleek and professional. Wet blade attachment, the most critical step, only performed by the most experienced craftsmen. The blade is sharpened using water to keep it cool, ensuring precision and durability in the final product. Only the most skilled craftsmen handle this step. They use water to keep the blade cool while sharpening, which ensures the blade stays precise and durable. It's where the final edge is perfected, making sure the knife isn't just sharp, but built to last. Did you know that over 500 billion cardboard boxes are produced every year worldwide? That's more than 1,500 boxes per person on the planet. First, we start with print processing. Massive printing machines apply designs, logos, and information to the cardboard sheets. This step transforms raw cardboard into customized, branded packaging in just a few hours. In the print processing stage, the massive printing machines used are often called flexographic printers. These machines are highly advanced and capable of printing on various types of surfaces, including cardboard. One interesting fact is that these printers use flexible plates, which allow for rapid changes in design and high-resolution printing. This flexibility is crucial for producing customized and branded packaging quickly. Next, the printed cardboard moves to the cutting section. Here, it's automatically cut to precise sizes based on specific product requirements. Any leftover scraps from this process are collected and recycled, making the process both efficient and eco-friendly. An interesting aspect of the cutting section is the use of advanced die cutting technology. In this process, large metal dies are used to cut the cardboard into precise shapes and sizes. These dies can be custom-made for different box designs, allowing for intricate cuts and folds with high precision. Now we move to assembly and gluing. Advanced machinery, controlled by data inputs, assembles the cardboard into various shapes and sizes. Glue is applied with accuracy, ensuring each box is securely formed and ready for use. In the assembly and gluing stage, machines use data inputs to precisely fold and glue the cardboard into various shapes. One interesting feature is the use of automated glue application systems, which apply just the right amount of adhesive to ensure a strong bond without excess glue. This technology helps maintain high production speeds and ensures that every box is securely formed. For the final touches, the binding process comes into play. Using a foot pedal, the factory workers efficiently strap and bind the completed boxes, preparing them for transport. This step ensures that everything is neatly packaged and ready to ship. This simple yet clever tool not only speeds up the process, but also helps ensure that every box is neatly secured and ready for shipping. It's fascinating how such a straightforward mechanism can play a crucial role in maintaining order and efficiency in the packaging line. This step is essential for ensuring that the boxes are well organized and protected during transport, showcasing the blend of manual skill and practical design in modern manufacturing. Once the boxes are bound and checked, they're moved to the shipping area. Here, the finished products are organized and prepared for distribution to stores, warehouses, or directly to customers. Kyowa Bronze utilizes Japan's only reverberatory furnace for bronze refining. This furnace is essential for achieving the perfect melt. The process involves reaching temperatures close to 1200 degrees Celsius. Watch as skilled craftsmen manually manage the furnace, carefully controlling the heat to melt the bronze ingots. Observe the bronze ingots as they melt in the furnace. The molten bronze, glowing with a fiery orange hue, is highly fluid and must be handled with extreme care due to its intense heat. Precision is crucial to ensure the molten metal is ready for the next step. For the casting, we use a sand mold specifically designed for impellers. First, the sand mold is heated to drive off any moisture. This step is crucial to prevent steam from interfering with the metal pour. Next, a chemical agent is applied to the mold to create a smooth surface and make it easier to remove the metal once it solidifies. Now, the molten bronze is poured into the preheated sand mold. This step requires precision to ensure the metal flows smoothly and fills every cavity of the mold. The high fluidity of the molten bronze ensures a detailed and accurate casting, but also makes this step risky. After pouring, the molten bronze is left to cool and solidify at room temperature. This cooling process allows the bronze to take the shape of the impeller mold. It's a crucial phase where the metal hardens into its final form. Once the bronze has cooled and solidified, the next step is to remove the impeller from the sand mold. A vibrating machine helps shake off any sand that may still be clinging to the metal. This ensures a clean finish and prepares the impeller for further processing. The impeller is then polished using a sandblaster. This process removes any remaining impurities and smooths out the surface of the impeller, preparing it for the final shaping. Next, the impeller is precisely shaped using specialized machinery. This step ensures the impeller meets exact specifications and has the necessary features for its intended use. Fieldwork is an important part of the process. A ditch is dug to test the centrifugal balance of the impeller. By rotating the impeller, heavy parts are removed to achieve perfect balance, ensuring it functions correctly in its application. The process starts on the first floor with the matching of boards. These boards are made from cedar and cypress trees, sourced sustainably from forests in the USA. The wood is selected carefully for its durability and smooth finish, ensuring the best quality for pencil production. Once the boards are prepared, they are hollowed to create space for the pencil lead. The hollowed planks are set into a machine where the lead is carefully inserted. The pencil lead itself is a blend of pigments, dyes, talc, wax, and glue. This special mix is what gives the pencil its smooth writing capability. Next, nori, a type of glue, is applied to the bottom board. The pencil lead is laid into the groove, and then the top board is placed over it, forming a pencil sandwich. This process is crucial to ensure the pencil lead stays securely in place during use. The glued boards are then fixed together and sent to a drying chamber. The drying process is essential to ensure the glue sets properly and the boards are firmly bound. Once the boards have dried, the real transformation begins. The pencils are molded by machines that shave the wood into various shapes. Depending on the cutter used, the pencils can be hexagonal, round, triangular, square, or even heart-shaped. The versatility of shapes allows for a range of designs. After shaping, the pencils are cut. The machine cuts one side of the pencil first, then flips it to cut the other side, ensuring precision on all sides. The cutting follows the natural grain of the wood to maintain strength and integrity. With the cutting complete, a prototype of the pencil is ready. Each pencil is now an individual piece, separated from the wooden board, and moves on to the next phase of production. Now it's time to give the pencils their color. They pass through a high-speed ink machine where vibrant layers of paint are applied. The pencils are then sent down drying lanes where the paint hardens and sets. Craftsmen inspect each pencil for any uneven application, ensuring that the color is consistent and smooth. Once painted, the pencils move on to the printing phase. A specialized machine prints the brand name, "Made in Japan," and other details along the side of each pencil. The label can vary in design depending on the product, giving each pencil a unique look. For some pencils, like the classic white ones, intricate patterns are printed using a rolling technique. This ensures the label wraps perfectly around the pencil, maintaining its clean, elegant design. After printing, excess ink from the pencil tip is polished off to leave a clean, sharp finish. Workers meticulously check for any imperfections, ensuring the ink doesn't interfere with the pencil's function. Before the pencils are ready for shipment, they undergo a sharpening process. Each pencil tip is sharpened uniformly to provide a consistent user experience. Red pencils, in particular, receive special attention to ensure they are precisely sharpened. After sharpening, the pencils are inspected one last time. Any remaining imperfections are addressed before the pencils are packed and prepared for shipment. Each pencil is now ready to head out to stores and users. This factory produces an astounding 6 million pieces of chalk every year. We start the process with calcium carbonate chalk, commonly known as Eco Chalk White. This type of chalk is made from calcium carbonate powder, which is mixed with glue and water to create the base material. To reduce waste, defective chalk from previous batches is also added to the mixture. The workers carefully measure out the ingredients to ensure a consistent mix. As the glue binds with the calcium carbonate, the mixture begins to take on the smooth texture needed for chalk production. Once the ingredients are combined, the mixture is blended using large industrial mixers. These machines knead the mixture until it's perfectly smooth and uniform, making sure the chalk is durable and long-lasting. While this process takes place, the production of gypsum chalk is also underway. Gypsum chalk, another popular type, is made from gypsum, which is known for its natural hardening properties when mixed with water. Workers carefully blend the gypsum with water in precise quantities to form a paste-like mixture. After the gypsum mixture is ready, it's poured into special molds. These molds determine the size and shape of the final chalk pieces. Since gypsum hardens naturally, it doesn't require any heat to set. The chalk is left to firm up inside the molds for a specific amount of time. Once the gypsum chalk has fully hardened, it's removed from the molds and laid out for inspection. The factory workers manually screen each piece, checking for any defects or imperfections. This attention to detail ensures that only the best quality chalk is used. While the gypsum chalk is inspected, the calcium carbonate chalk base has been aging for a full day. The aging process allows the chalk to firm up and become easier to mold. Next, the chalk mixture is fed into an extruder, which shapes it into long cylinders. These cylindrical shapes are then passed through round metal cutters to form individual chalk sticks. The cutting process is precise, ensuring each stick is uniform in size. The freshly cut calcium carbonate chalk is still soft, so it undergoes a drying process using heat. The chalk is placed in a large drying chamber where hot air circulates, removing excess moisture from the chalk and hardening it. To ensure a durable finish, the calcium carbonate chalk is left to dry for an additional day, making it ready for use in schools and other settings. Next, let's take a look at a specialized type of chalk, the thick red plaster chalk, which is widely used at construction sites. This type of chalk is made similarly to the gypsum chalk, but is much thicker, requiring a longer drying time. After mixing and molding the red plaster, the chalk is left to set for an extended period to ensure it's durable enough for heavy-duty use. Once fully hardened, the red plaster chalk is inspected and trimmed to size. Before packaging, both the calcium carbonate and gypsum chalk undergo a final quality control check. Factory workers inspect each piece to make sure it meets the company's high standards. Defective pieces are removed from the line to be recycled in future batches. With quality assurance complete, the chalk is packaged in boxes, ready to be shipped. Whether destined for classrooms, construction sites, or art studios, these pieces of chalk are now prepared for their final destinations. This company has been producing high-quality globes for over 86 years. The process begins by marking the globe's equator and the longitude lines. Precision is key here. Accuracy to the last inch is essential to ensure the globe's maps align perfectly. The globe is also marked at the top, and care is taken to wipe away dust or hair to prevent anything from sticking to the surface during production. Next, the globe's map sections, which are printed on fine coated paper, are carefully cut. This paper, similar to what's used for posters, is durable and ensures a smooth finish. Each section is aligned, starting from the equator, and is applied meticulously so that no air bubbles form. Did you know? The first globe was made in the 2nd century BC by the ancient Greek scholar Maros Crates, and it was brought to Japan by Christian missionaries in the late 16th century. The map is printed in 18 boat-shaped sections to make it easier to stick onto the spherical surface. The workers press each section onto the globe, ensuring it fits snugly against the curvature, while using a cushion to press down the edges and avoid air pockets. For a seamless finish, a hairdryer is used to gently heat the map sections, ensuring they stick securely to the globe. After applying the map, the entire surface is carefully checked for wrinkles or irregularities. Any imperfections are smoothed out, leaving the globe looking flawless. Next, holes are drilled into the globe for the time difference indicator board, which will be attached later. The time difference board is now carefully screwed into place. This part of the globe is not just decorative, but also functional, helping users understand the time zones across the world. With everything securely fastened, the large globe is complete, and it spins smoothly on its axis, just like the Earth. Now, let's look at how small globes are made. These globes start as 18 petal-shaped pieces of cardboard, each representing a section of the globe's surface. The base paper is pressed firmly against the globe's core for 30 seconds, ensuring it sticks properly. This pressing process helps shape the northern and southern hemispheres. After pressing, the northern and southern hemispheres are carefully shaped with a cutter, ensuring the edges are smooth and ready for bonding. The worker then applies glue to the edges of the hemispheres and fits them together. They repeat the process for both the northern and southern halves, making sure everything is perfectly aligned. With both hemispheres prepped, the final step is connecting them. A bond is applied to the edges, and the two halves are gently pressed together. To prevent shifting while the glue dries, the globe is taped securely. Once the glue has set, the globe is finally complete, accurate, smooth, and ready for use.